Today's video will explain many of the details of the UML class diagram. Hello, I'm James Helfrich. Most of us, when we use a class diagram, only use the class name, the attributes, and the methods. But it turns out the class diagram allows us to describe many other things. This video will explain those other details and show us how we can use them. A class diagram is a one-column, three-row table, where the first row represents the name of the class, the second contains a list of the attributes, and the third contains a list of all the operations in the class. And so the first is the name of the class. The second row is the attributes or member variables. And the third row is all the methods or member functions. But it turns out there's more to it than that. So we can specify the package name. In other words, is this part of a namespace or is this a nested class in the class name? We can specify a template. Is this a template method? For an example, in C++, the vector class has a template that specifies the data type of the underlying elements in the vector. We can have public attributes with a plus, and we can also specify the data type if we choose, and this is optional. And you can specify the exact name of the data type, like int, if you're going to use C++, or we could say integer, and that's going to be language independent. Protected attributes use the hashtag or the #. And this means that this particular member variable is visible both to this class as well as to derived classes from it. And we can also specify whether it's read-only with curly braces read-only. A tilde means a package attribute. In other words, this is visible not only to this class, but also all other classes within this containing package. We can also specify numerosity. For an example, if this is an array of 10 elements, then we can specify 10 or star for many or 1 to 5 or any other numerosity we choose. Private attributes are a minus, which means only this class can see this member variable. And we can also specify the default value, and usually this is created in the constructor. The slash means a derived attribute, and this requires a bit of explanation. Let's say that my class name is a derived class. Then we are going to have access to this member variable if it's public or protected, if it's specified in the base class. And so I'm going to list all the derived attributes if I choose, just to let me know what I have access to. Some people choose not to use derived attributes when they use derived classes because they could just look in the base class and see them. They think it adds clutter. And other people think that it adds a little bit of clarity because I can see exactly what member variables are visible to this particular class. But it's an optional thing. And finally, static public attributes are underscore. And recall that static means that all objects of this class share the same member variable. Now, with methods, we have a bunch of other things we can say. Public operations, just like public attributes, use the plus. Protected operations, which means it's visible only to this class as well as derived classes, use the hashtag. And I can specify the return type optionally if I choose. And just like with attributes, I could specify the actual name, like double, or I can say real number, whatever you choose. Tilde, just like attributes, mean this operation or this method is visible to this class, as well as all other classes in this namespace, or if it's a nested class, to its base class. I can also specify parameters if I choose. Some people always put attributes in the operations section of the class diagram. Other people don't because they think it's obvious. That's completely up to you. Private operations use the minus. And notice that I can specify the data type of the parameters optionally if I choose to. Derived operations use the slash just like derived attributes. And I can also specify whether a parameter is input, whether it's output, or whether it's input and output. Not all languages allow us to do this. Many languages, for an example, say that parameters are input only. But for an example, in Python, parameters are by default both input and output. And of course, in C++, you need to specify it by reference in order to make it both input and output. Virtual is italic, which means that the derived class can overwrite this operation. And a pure virtual operation uses equals 0. And this means the base class explicitly does not define it, and all the derived classes do, which means it's impossible to instantiate an object of that base class if it has at least one pure virtual operation. And that makes the class an abstract class. And finally, I can have a static operation just like a static member variable. And the trick about this is static operations can only access static attributes. Okay, pause the video here and see if you can fill in the blank for the symbol corresponding to each of these meanings. Okay, Let's continue now. If a class is a stereotype or a template, then we use the dash 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 line in the upper right-hand corner of the class diagram. The name of the class, that goes in the first row. The public modifier applies to attributes and operations. We use the plus. The protected modifier applies to attributes and operations, and that's the hashtag. The private modifier applies them once again to attributes and operations, and that's the minus. When an attribute is shared with all the objects of that class, that means it's static, and that's going to be an underscore. When a method is a virtual, meaning the derived class can redefine the method, that's italic. We can specify the data type of an attribute, a parameter, or the return value with a colon and then the data type. If an attribute or parameter has more than one element in a collection, we use a square bracket and the numerosity. When a parameter cannot be changed, we use the curly brace and then read only. When a method takes parameters, we use parentheses, which is how most languages specify that there are parameters. And the default value of a parameter, we say equals and then the default value. You can learn more about class diagram elements in the class diagram elements section of the class diagram chapter of the software design textbook.